Okay, good morning, good afternoon, and good evening, colleagues. Welcome to our next ECHO session. My name is Francis Ochen. I'll be your moderator today. Very delighted to be your moderator today. Apologies for the change in time that might have disorganized your normal routine for the ECHO sessions that we run. We hope that you can understand. This is going to be a 1 hour long session with two presentations. The first is a brief one and a second presentation, then we'll follow it up with a question and answer session. We will have simultaneous language interpretation, and we encourage you to choose the language of your choice. Get to the bottom of your screen and get to that icon of the globe and choose French if you're French speaking, or English if you're English speaking. Keep on one of the two channels for you to get the real-time interpretation as it runs. Today's session is going to be focusing on the neglected tropical diseases and the lab network. Many neglected tropical diseases laboratories intimate potentials to act as reference laboratories, but information available indicate that only a fraction of the reporting institutions actually apply comprehensive quality management systems in their day-to-day activities. Our session today, that's going to be run by the team from the German Epidemic Preparedness team, will present a study that aims to validate a new nucleic acid amplification test for the diagnosis of one of the neglected tropical diseases, and that is yaws infection. And then we'll also discuss the general need for One Health-oriented cross-sectional EQA programs down to the different levels of laboratory services delivery. We'll then also present the LAMP for yaws project as a possible blueprint for other diseases programs and external quality assessment for tropical countries. We are delighted to have two presenters today. Our first presenter is going to be Dr. Andreas Gildorf. He is the head of the German Epidemic Preparedness team, and he will be dealing with the introductory session. And then our second presenter is Dr. Sasha Nov, and he's the head of the Institute of International Animal Health, Stroke One Health Federation, a research institute for animal health in the ISLs of REMS. Colleagues, join me in welcoming Dr. Andreas to take us through the first introductory session. Dr. Andreas.
Yes, thank you very much, Francis, for the nice introduction. It already takes some of the things I wanted to say, but I'm happy to be here. And like you said, the first presentation is about the German Epidemic Preparedness team that I'm happy to head, and that has been asked by your colleagues and you to bring together the information that we're presenting today. And before Sasha is taking over, I take the opportunity to introduce you very shortly in a couple of slides what the German Epidemic Preparedness team is. It was founded in 2015 in the aftermath of the Ebola outbreak in West Africa, when the Ministry of Development in Germany, in cooperation with the Ministry of Health, have decided that Germany should be a stronger actor in supporting partner countries when there are outbreaks of infectious diseases. And we have been joined in this year also by the Ministry of Agriculture. So you can see this is really a One Health approach that we are building on, and that we're really trying to put into our support activities. What is the goal of the SEG? SEG is the German abbreviation for the German Epidemic Preparedness Team. The goal is really to provide technical support to partner countries with expertise for outbreak response and pandemic preparedness. And the focus is really on this technical support because we are a group of German technical institutions with a long-standing expertise. We have 5 institutions right now, and to give you an understanding of the wells of experience and the width of knowledge, I'm shortly taking some time to explain the 5 institutes that we are representing. The first one where I'm based is the German Development Agency, GIZ, and this we are supporting countries in helping to improve their many systems, but especially the health system. And in the GIZ, the core team and the coordination of the SEG is placed. Then we have the Bernhard Nocht Institute for Tropical Medicine with a long-standing experience with tropical diseases and a lot of local offices as well. Then we have the Robert Koch Institute, which is the German Public Health Institute, in charge of advising German governments on all topics on public health, like surveillance, crisis management, and also much more investing into international cooperations, also with African CDC, for example. Then we have the Friedrich Löffler Institute, where Sascha Knauf is from. That's the German Animal Health Institute. And like Francis said, there is now also an international department, and that helps in the efforts to strengthen also all the pandemic preparedness measures with this One Health approach. And then the 5th one is the Charité, which is one of the biggest university hospitals in Berlin, which brings in a lot of diagnostic capacity, but also has a wide knowledge that we can tap in from the SEG, and this is helpful from our cooperation side. But what is exactly the SEG doing on the ground? So our core expertise is really in strengthening laboratory diagnostics. We are helping with the processes and structures for health emergencies, but also support with cross-sectoral pandemic prevention and response measures. And we try to use wherever possible a One Health approach. And since 2015, when we were founded, we supported more than 20 countries all over the world with more than 40 deployments. And the focus of these deployments were really on Africa and Latin America. This is all over the 6 years, but we really got a strong booster in requests and also our ability to support during COVID. And here's just a visualization of just the COVID deployments that we did in the last 18 months, 20 deployments, again with a strong focus Africa and Latin America. But maybe also interesting for you, your colleagues, how is the SEG activated? How can you get help from us? And this works through a request. Normally that's an initial request that should come through official channels by the national government, and it can go through our Ministry of Development or through the embassies. And once it reaches us in the SEG, we do a first appraisal and we see is the request mapping well with our expertise, really to see what we can provide, how we can support. And then we, to also define that, we're getting into contact with you on the national level, the national experts, to define better where have you identified gaps or areas where support from our side can be helpful. And then we discuss it together in our SEG steering group. And once we think that is really a good match between what you need and what we can provide, then we suggest that as a deployment to our government, to our ministries, and then they have to approve it. When they have to approve it, we have kind of green light to go into the planning process. And this then is really a process depending a bit on the urgency as well. Recently, we had many support requests in really building capacity on diagnostics, on pandemic preparedness, that sometimes needed some time to organize all the administrative things, procurement where necessary to travel. And it also depends a little bit on the requests and workload that we had already. So it can take a bit of time before we are then really on the ground. But depending on the urgency, we also can reprioritize, of course, the order of the requests we're having. And these deployments normally last 1 to 2 weeks, depending really on the topic, and bring together the experts from the different institutes that we are representing, and is often really focused and targeting on 1, 2, 3 questions where this technical exchange that we want to stimulate really brings the added value that such a deployment then really should bring. Important it is for us also when we're looking of kind of sustainability, or at least to tap into longer lasting support, that this is really embedded in the national structures and supporting the national system wherever we can. And this is just to give you a very fast and short overview about what the SEG itself is, that you get an idea for that, and also maybe when you hear it again or where you think we could be useful, that you know how the SEG is working. And through this channel, we were also asked now to present here experiences from the different partners. And today it starts with Sascha Knauf, who is presenting his topic, and I am happy to hand over back to you, Francis, or to Sascha.
Thank you very much, Dr. Andreas. Let me not take any more time. I will invite Dr. Sascha to take us through the LAMP for Yours project. Thank you very much, and you're very welcome.
Yeah, thank you very much, Francis. First, most important question, does it work with sharing my screen? You see this?
Yes, we can see the screen.
Perfect. I will reservoir, a non-human reservoir, then the whole system becomes very, very complicated. And we do have 2 neglected tropical diseases that are currently subject to eradication. This is guinea worm and yaws. And I would like to switch now to the yaws case. Yaws is targeted by WHO worldwide for eradication in 2030, so 0 by 2030. That's defined in the NTD roadmap, and we are in the 2nd eradication campaign. What you see here in yellow is the area where human yaws was present before the 1st eradication campaign. You can see that the 1st eradication campaign was a success because it reduced the prevalence of yaws, but it didn't eradicate it globally. The estimated costs for eradication of yaws today are 100 to 500 million US dollars. That means you're talking about a substantial resource that you need to eradicate this disease. Now, yaws is a nasty disease. It's not a killer, it's a disabler. It starts with lesions on the skin, and if it progresses over 3 stages, then you can enter a tertiary stage where you have a severe deformation of the cartilage and bone, and it's really stigmatizing those people, and there is no question that we want to eradicate this disease. This is how Treponema pallidum infection, so yaws, looks in non-human primates. African non-human primates are infected with the same bacterium. So we could show in 2018 that this pathogen is not an exclusive pathogen of humans. It's a pathogen that can also be found in wild non-human primates in Africa. Now you can see the whole thing becomes quite complicated. On the one end, we are in the end stages of human yaws eradication. We want to eradicate the disease by 2030. On the other hand, we have pretty good data showing that this pathogen has a reservoir, not knowing whether there are continuous spillovers, whether African non-human primates are the source for new human infections, but definitely we can show that this is the same pathogen. And so the whole system becomes quite complicated. Either way, whether you want to eradicate it or whether you have to monitor new spillovers, you need quite good diagnostics. And this is where the LAMP for Yours project comes in. The spirochete Treponema pallidum, subspecies Petuinae, is causing yaws, but closely related is Treponema pallidum, so causing syphilis, and Begial causing endemic syphilis. It's a chronic infection, as I said already, affecting the skin, bone, and cartilage. and it's associated with poor access to water, sanitation, or known, and these are known predisposing factors. What is the problem in yaws? The yaws problem is that many skin diseases look similar. Treponema pallidum can cause these ulcers, but it can also, for example, be caused by Haemophilus ducreyi. So looking at these lesions doesn't tell you anything. That's one thing. Of course, when you want to eradicate a disease, you need to know whether the new ulcers that you see in an area are caused by maybe the pathogen that you thought is eradicated, or whether they are caused by other bacteria. And it can be difficult to do this based on the clinics. Yaws infects persons in several stages of primary yaws, and then you get secondary yaws, and in between you have also latent stages. That means you are clinically healthy, but you are still infected. You can't get rid of the bacterium if you don't get antibiotic treatment. But if you have latent yaws infections where people look clinically healthy, it's quite difficult to say whether they are infected or not. But of course, when you go, again, if you want to go for eradication, you have to be sure that there are no leftover latent cases. What's another problem? The problem is that Treponema pallidum elicits a strong antibody response. And you cannot distinguish between syphilis, yaws, and Beagil based on the antibodies. That's a very closely related or conserved bacterium across the different subspecies. And so you can only go for antibody detection. You use two types of tests. One is treponemal tests, where you detect antibodies directed against the bacterium. It is highly specific, but it remains lifelong seropositive. So even if you are successfully treated, you will have antibodies and you can detect them. So you cannot say anything about successful treatment or not. Another thing is, if you use non-treponemal tests, those tests are detecting antibodies directed against cardiolipids. It's a lower specificity, but it can be used as a treatment control, because what you can see here is after time, and it's frankly quite a long time. But if you're successfully treated in your life history, then these antibodies should be negative over time. Whereas if you stay untreated, if you still have an active infection, they remain positive. There are pretty good rapid tests. And for this reason, the WHO is also currently recommending mass treatment and also detection of new cases or remaining cases by a two-step process. It starts with a single test. You can use a syphilis test. As I said, you cannot distinguish between yaws and syphilis. If it's positive, then you will use a second test, the non-treponemal test, and this will give you an idea whether you have a current infection, whether it's a past infection, or whether whether there's no current or past infection. So the problem here is it's quite complicated, it's quite resource demanding, and there's still a lack of discrimination between different treponema subspecies. It might also be that you have syphilis cases in young adults that you cannot distinguish from yaws. And also the problem is that there is antibiotic resistance or antimicrobial resistances that develop based on the treatment with oral doses of azithromycin. So you want to also detect those antibiotic resistant strains. So you can see it's quite complicated. And honestly, that's also the reason why at the same time, and maybe that's also explaining why we are not so many attendance here. There's a webinar about the need for innovative NTD diagnostics to achieve those goals set by the WHO to eradicate or eliminate diseases. So I'm thankful that you are participating here and that I can give you some insight about what we currently do. One aspect of overcoming serology is doing nucleic acid amplification. And one tool that you can use is the loop-mediated isothermal amplification. That means you have primers, some more primers than the normal PCR, where you have only the forward and backward primer. But here you combine different primers, the F3 primer, B3 primer, and the BIP primer. And your target DNA is used to create with these primers hairpins. And with this hairpins, you can start a reaction. It will exponentially, it works exponentially. And through this massive amplification of DNA, the process starts, and you can then visualize it either by fluorescence readout with equipment, or even by the naked eye if you just use a fluorescence lamp, a lamp for fluorescence detection, or even without fluorescence, you would be able to see whether this sample was positive. That means you have a very specific reaction that uses nucleic acid that you can use to demonstrate whether a pathogen is there or not. If you go a little bit further, and that is done in our partner laboratory, who's also part of the Lamp for Yours project, you can do the same thing, what I showed you already. You amplify the DNA, you get these hairpins, but then you couple it with a mediator probe. And this probe will be released through amplification during the reaction. And the clue here is that the mediator probe will then bind to a displacement system, a probe, and then it will start to show you the fluorescence. Now, because you can perfectly adapt this to the different pathogens, that this system allows you now to do multiplex. That means you can detect in one reaction multiple targets, different pathogens or antibiotic resistance. So that's the reason why we use the mediator displacement lamp. We have designed such a lamp already for Treponema pallidum using the polymerase I gene, and also for Haemophilus ducrei targeting the 16S rRNA gene. And the limit of detection is similar to what we have found in qPCR, which we set as a gold standard. There's a high analytic sensitivity and specificity of the Singleplex assays, and that is the clue. You can run these reactions under isothermal isothermal conditions, means you get rid of very expensive laboratory equipment. So the advantage is it's a sensitive, specific, and fast assay. You don't need the sophisticated thermal management. It is cheaper, and it can be used as a point of care and point of need test right at the site where you have the patient. So on the district level. It is adaptable to also detect resistances. The disadvantage, of course, it's not high throughput. You can see this device here that you use as a thermal device. You can't. It has only slots for 12 reactions, so you're quite limited in this. And of course, you still have to order oligos, which is in many ways in Africa maybe problematic. But nevertheless, I think it's a very valuable and promising tool to support yaws eradication, and that's the reason why it got funded by the EDCTP, so by the European Union, to be a study to clinically evaluate this test for yaws eradication. And it's currently ongoing. It goes from 2019 to 22, and we are right in the middle of this project. And this project is focused on West Africa, in the 3 countries that contribute most of the yaws cases on the African continent, which is Cote d'Ivoire, Ghana, and Cameroon. And the goal of this project is to validate this assay on the district level, because we see that this is a front line of disease control. It's not the reference laboratory itself. It's really those laboratories that get the first cases. It's going along with capacity building, external quality assurance, and it should ease also the detection of resistance detections in yaws cases, and also has an outreach component where we want to disseminate those things. This is basically how the project is working. We have several work packages, and you can see along those 3 countries, one work package is also the external quality assurance program. And we want to use this program later on as a blueprint, and maybe also to team up with other programs to really establish a technically sound EQA system designed for the tropics, and also including the district levels. The study is screening quite a lot of people. So in all 3 countries, we expect to screen 60,000 people. Of this, we will then go through the algorithm that I showed you already set by the WHO for testing for yaws and detecting the last yaws cases. And we expect that we have then about 200 positive cases, and we also include 10% of asymptomatics just to be on the safe side so that we can validate this test in a proper way. If a person gets sampled, then of course in the laboratory, and that is now the component that is obviously of most interest for you, if the person gets sampled, then of course the sample goes into the laboratory. You need to extract the DNA, and here I indicate where are the critical control points, where are those points where you can fail. Then on a district level, we are doing the LAMP assays. You have to validate the LAMP and you have to establish it in those district levels. And then also simultaneously, those samples will be retested by qPCR by the national reference laboratories. And that all goes together then as a data set to validate those things. And I'm sure you would agree that high quality laboratory work is the backbone of any disease control, elimination, or eradication program. If trash in, trash out. If you bring in bad samples, you will get bad results back. And you have to be sure, even on the district level, that those results are reliable and that that they really can accurately detect positive and negative cases. There are a number of international standards, as the DIN, EN, ISO 15189, and so on, for medical laboratories, requirements for quality and competence, and so on. You probably know all these international regulations, but think about how many national reference laboratories and also how many district level laboratories you know that apply those rules. And even if they want to apply those rules, sometimes they are not able to do this because simply the infrastructure is not there, or they have problems to fulfill those things. So the problem statement is also that, and this was also mentioned by Francis in the beginning, many NTDs laboratories believe that they could act as a reference laboratory, but only a fraction of a study reporting institutes applied those international and those national and international standards. So we have to create a structural program where we combine the national reference laboratories with the district laboratories to really increase EQA and PT programs, because that is the only way to control the quality and to achieve the goals that are needed to have a laboratory accreditable to really help to fight the eradication or elimination of diseases or control them. Now, you all know that there are different levels of national healthcare. It starts, or the laboratory levels. It starts with the national reference laboratory. That is often able to perform the gold standard, the qPCR, but it's quite expensive, those devices. And then it goes down provincial level, district level, healthcare center, dispensary, and community. When you run an external quality assurance program, you can combine those different levels, and you can compare also the performance of the laboratories that participate. You can do this on the reference laboratory level, but also on the district level. And you can also compare the different testing sites. And if we are able, if the LAMP assay is holding what it promises, we would be able to establish a pretty lightweighted setting in terms of costs on the district level that would also serve especially down to the dispensary level, because you could also potentially run those assays in well-trained dispensaries. Now, what comes along with an external quality assurance? Of course, it's an on-site monitoring that needs to be done regularly. It is an organization of proficiency test rounds that in our case is biannual. So laboratories have to receive these proficiency tests and they have to do the analysis within a certain given time. And then you have the retesting of a subset of samples, of course, done by either the reference laboratory and or a partner laboratory, an external one. And that is done on a yearly basis. The expected outcome is that we can compare the performances and results along the different tests, along the different test sites. It will allow us to identify areas that need improvement and training needs, and that is also where the SEG can come in, where we need more training in those laboratories. It can help to have an early warning system for systemic failures in disease programs. And of course, the objective is to have a proven evidence for the testing quality in those programs. And that goes somehow into the direction of the classical hazard analysis critical control point system, where you define critical control points and where you monitor those points and where you can take proper adjustment in case something goes wrong. However, this is all easy said when you come from Europe or a Western country that is comparably rich, but we have to recognize that there are different needs, and in particular in low-income settings, we have to deal with significant limitations in resources. It's difficult to ship samples, especially if they need to be frozen. You deal with a lot of unexperienced laboratory workers, and there might be also problems and challenges with weak communication infrastructure, simply because in many ways the network is not functioning. You cannot make, sometimes even phone calls are difficult, or Zoom or participating in those in a Zoom conference like we do it now. So that means and meant for us that we did a first situation analysis. We went to those partners and looked for the laboratory quality management. What are the supply chains? Would they be able to get the PCR items that they need to perform the LAMP and qPCR? How about the internet? What is the current infrastructure? Is there a thorough supply of power or water? And so on. So many questions that need to be answered before you start an EQA program and before you can design it to fit the purpose. Another thing that we were thinking about is, what are those proficiency test items that we send around? You can use whole organisms, but you must know that Treponema pallidum, for example, cannot be grown artificially, or it's very challenging. And of course, if you use whole organism DNA, you would not be able to distinguish from wild type infection. So in case of contaminations, you have no tools at hand to identify a contamination. For this reason, we decided that we use synthetic genes. We used plasmids that contain the targets for our assays. And of course, there's a higher risk of contamination because plasmids are quite stable. And if you work with them in high concentrations, then you have to be quite careful to not contaminate your laboratory. But the good thing, though, is you can distinguish them from the wild type infection. You could use M13 primers, and they would exactly give you an idea whether your normal samples are infected with wild type or whether it is a plasmid infection, a plasmid contamination. And finally, and that's also a good thing, you can dry them. You can lyophilize those plasmids and you can ship them without cooling across the African continent. And another thing, if you are a reference laboratory, for example, you could also transform E. coli with those plasmids and you grow new plasmids. So you would serve with one run probably for the next 10 years or more your country, or even large parts of Africa with enough positive control samples. So these are the plasmids that we use. They are ordered from Eurofins, and here is your gene indicates where we have included our target gene. And so this is a pretty nice way of establishing proficiency testing items. But of course, if you think about the samples itself, we expect a human background DNA, because those samples that we use in the program are from humans, swab samples. And so we not only included into the proficiency testing item panel the target plasmids for Treponema pallidum and Haemophilus ducreyi, because that is the most important differential diagnosis for these yaws lesions. We also included human cell material, tissue culture that is used and then also spiked onto these swabs. You see that we have 7 swabs here. All are spiked with the same amount of human tissue, but then in the plasmids that are used for the different organisms, we differ. So we have high, 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 low, low, high, and so on. You see, we have different constellations. We have also swaps where we do not have any targets on it, and we will mix those swaps and use them as a blinded panel that we send out from currently Reims in Germany to our African partner sites to then be processed in the laboratory and to report back the results. So that's a good thing. So far it works nicely. Here you can see how it's organized. We send out the proficiency test panel in a single package now. It's a little bit revised. We don't send it from here to also the district laboratories because that's logistically a little bit more complicated. So we decided we put everything into one package. We send it to the National Reference Laboratory, and from there it then goes to the district laboratories. And once they have received those items, they have to report back the results. We are currently exactly at this stage. The packages are sent out and we are expecting to receive the first results soon. This is how it should look like. That's an example for batch testing in the qPCR. You see we have the seven swaps. The laboratories do not know which constellation was on it. So this information, what you see here, is not visible to the laboratories. And they report back whether you have an extraction that was successful. That's also a reason why we include the human cells, because that would mean you really have to extract DNA. In plasmids, it would not give you an idea about the successful extraction. And then with the plasmids, you can see that they have to report back which ones were positive with high numbers, target numbers, and low numbers, and so on. So when we receive this back, we can then give feedback to the laboratories. On our end, as the proficiency test item provider, we also have to make sure that those plasmids are stable over in many different conditions, and that is currently work in progress, but it looks so far quite promising. We test different humidity, different room temperature levels, and so on, because you want to be sure that even if a parcel is sent, I don't know, in the Congo, and then it is forgotten in the sunlight and somehow the temperatures get very high inside the package, that still the plasmids and the samples have the same good quality than the one when you shipped it to the place. Now, external quality assurance is one thing. It guarantees the implementation of internal quality control and proficiency testing quality improvement, but SOPs are also another important aspect of this because it is the installment. So the standard operation procedures are the installment that is important towards quality assurance and reproducibility. For this reason, we have a handbook that is hopefully then after the project available to all other disease programs, where we have different SOPs, and the participating laboratories have to follow these SOPs, and that also includes the EQA scheme that is implemented into this yaws eradication program then. And we hope that this will serve as a blueprint for other disease programs down to the district level to be included into external quality assurance. So you don't see seven swaps here, but just for demonstration, we send out the blinded set of samples. They have to be processed the same way as it is done with the patient samples. If everything is well, it is in concordance, then the laboratory is able to continue going on with their sample testing in human samples. If it fails at one of these stages, let's say, for example, the extraction success for the DNA, then it is a discordance result. And that would mean that we have to do troubleshooting and retesting with a new set of a new panel, and ultimately also perform a root cause analysis to find out what is the problem in this laboratory before they can continue to handle the routine human samples. So with this, you would have you have a pretty good system, even on the district level, that can be run by the National Reference Laboratory, and that ensures that there is a substantial quality control within disease programs. Now, the EQA summary is that EQA is a standard mean of quality assurance in medical laboratory diagnostics. I think it's pretty clear, and you can compare those results between the different peers, between the different reference laboratories, and also your testing sites. And the proficiency testing is a prerequisite to guarantee correct, standardized, and comparable diagnostic tests within and across those healthcare programs. And just today, I found a new publication from 2021 where EQA programs across One Health sectors in Asia, and I'm really talking about human and animal health. If you think about zoonosis, those EQA systems should be combined. You should have both included. These panels should be sent out to the animal laboratories, but also to the human laboratories to ensure that they all have the same quality. And here you can see what they do in Asia. They have a connection to Europe. In the human health part, you can see they have a lot of links here, and then also in the animal part. But you can see that it's not exactly the same. So I think combining and synchronizing those sectors, the veterinary part, also the human part, is a very essential component in the future for One Health-based disease control. And One Health-based disease control is the only control that is sustainable, because if you miss a non-human reservoir, then it's a problem. So the question is, can we do the same for Africa? Can we also set up programs where we combine the veterinary part and the human part? And I'm not talking only about rabies or something, because there are, of course, some good initiatives, but the overall concept is, can we combine those things? And can we also include not only the reference laboratories, as it is done here, can we also look more on the district level as the first line of defense when diseases need to be detected somewhere in the bush? And the conclusion is that EQA programs are an essential need for especially NTD programs. Currently, only Borrelia ulcer is including EQA. More EQA programs need to be done on the district level in Africa. That is what I demonstrated, hopefully, with the LAMP for Yours thing. And there needs to be an intersectoral program required to adequately address the One Health approach, bridging human and animal health. And combining multiple programs is the ideal. You want to save resources. It doesn't make sense to only send out panels for yours. Maybe we should combine them with rabies or with Borrelia ulcer or tuberculosis, HIV, or whatever you can think of where you see the need, especially in zoonosis, where you need to bridge those things. And with this, I would like to end my presentation. I'm thankful for all the partners in the LAMP for Yours consortium, and also special thanks to all our colleagues in Africa who support this study. And I would like to end with this slide, Never Stop Exploring. I hope I was able to motivate you a little bit. I think it's good to talk about One Health and to hopefully grow the community that agrees that we need to have more intersectoral or cross-sectional communication, even on the laboratory level. And if you want to contact us, then you feel free to send me an email. You have my email address here. Thank you very much.
Thank you very much, Dr. Sasha. Fascinating presentation, quite clear for all of us. Today, you took us away from HIV, COVID, TB to the neglected tropical diseases, among others, but in a very clear manner. We have questions and comments coming through that you will deal with colleagues that are part of your team. And also, I still encourage the participants online to please join the discussion through the chat room so that the next few minutes we can have some of your questions, concerns addressed. I have one question that I will start with, and this question is coming from Anafi. And Anafi is asking, what lessons from your EQA programs have you learned that can be applicable to other diseases, and vice versa? What can we learn from other diseases and apply to this program? That is one question. I'll add one to this. We do know that when scheme providers run external quality assessment programs, there is a provision for the on-site support. In your program, are you looking at the on-site support that will support root cause analysis by the scheme provider, let alone what the participating labs do? If that is yes, you could then also share with us what the justification is. I will have additional questions coming, but we could deal with the first two. Over to you, Sasha.
Okay, thank you very much. The first thing is the on-site support. We do have teams and that regularly visit those participating laboratories to do the on-site training and monitoring. We just started this year with intensive workshops to implement also the LAMP assay in those district laboratories. And our consortium functions in a way that we always look for train the trainers. So we have well-trained staff in the national reference laboratories, Institut Pasteur and others. And they are then available on the African continent to have somehow south-to-south collaborations where the colleagues from maybe Cameroon are then supporting people in Cote d'Ivoire, or people from KCCI in Ghana are then going out. And ultimately, if there's a real problem, then we would also be available to visit those laboratories and do the troubleshooting on the ground. But though the visit of the laboratories in this consortium is done on a regular basis by the consortium members. And with the EQA, we also have then an ongoing discussion if things are not working out properly. I have to say, there are a number of challenges that we are all facing that really starts from the shipping of items, you know, how long it takes until those items arrive, and also the communication things. But this is not new for people working on the African continent or with African colleagues. So we know this, but our idea is that we have to recognize those things. It doesn't make sense to apply national, international standards to laboratories in Africa if they simply cannot perform well because they don't have a good infrastructure in terms of networks, things like that. So we try to identify those critical points and try to provide then ultimately solutions to circumvent this. And our hope is that after the project is finished, we not only have a good validated test that can be used for yaws eradication in humans, but also we have learned a lot of things from the EQA implementation that then can be served, that then can serve other programs who hopefully then will adapt their programs to also include the EQA. What are other diseases? I think key today in disease control and eradication, it doesn't matter if you talk about animal health or human health, is to combine different programs. And as I said already, I think other disease programs, be it oral ulcer or onchocerciasis or guinea worm, will likely benefit also from included quality assurance programs in a standardized way. I mean, we all try to get the best out of our laboratories, and that is including our colleagues in Africa. But one thing is to try your best. The other thing is to demonstrate that you are good in what you are diagnosing there. And I could really see, in particular in zoonotic diseases, that there needs to be more EQA programs that cross-link between human and animal health.
Certainly, and we cannot use valid results if we do not have objective ways of assessing how good we are doing. I have a couple of questions coming. The next is coming from Abraham, and he says, your project on EQA is currently funded by the EDCTP. You're doing excellently well. What plans for the post-EDCTP funding? And what advice do you have for labs in resource-limited settings with respect to EQA funding? And he concludes by saying EQA is not cheap at all.
Yeah, that's true. That's true. The question for sustainability is always a very valid one. And in particular for us as FLI, with our new institute, we want to ensure that that we can really support our colleagues in low-income settings. That starts from looking at how can we strengthen the markets for consumables in Africa so that it becomes cheaper for those laboratories to get access to consumables. And it also is a valid question how it continues after the funding by EDCTP. Of course, we hope that the assay will be doing well in terms of validation. And if this is the case, we hope that there will be, for the yaws program, substantial funding available to implement this test on the last miles of human yaws eradication. But of course, in my view, even if spillover is very rare from non-human primates to humans, you also have to continue surveillance in areas where you have infected non-human primates. For this reason, you also need ongoing availability of these tests. Now, how can you finance this? I think partly it's also the motivation of the reference laboratories to also play their role in checking quality from on the district level. And as I showed you, for example, if you use plasmids, and once you have them, it's pretty cheap to, creating those positive controls is fairly easy, and they are not very expensive. So it's a matter of organizing to send out those items and of course having the consumables available at the district level. On the other hand, I mean, there's no benefit from having a district level laboratory if you cannot be sure that the test results are valid. So it will cost money, but it's well invested money. And on a long term, we hope that there is an initiative on the African continent that continues to implement those EQA programs across the different laboratories. And I would say that we as FLI, but also the DIG is very interested to support you in these initiatives. Bringing in the One Health aspect is also very important.
Thank you very much, Dr. Sasha, and very fascinating indeed. And like we already indicated, quality is key, but also being able to provide timely results is one thing with all the technologies that you've developed, including the new loop-mediated isothermal amplification platform that you have made available. We are almost getting to the top of the hour and we'll be closing it. And as we close, I have two quick ones. Dr. Andreas, can you please give us your closing remarks very briefly? Dr. Andreas, are you online? I can start with Sasha, please, your quick closing remarks.
Yeah, do you hear me? Yeah, I hope that with my presentation today, I was able to motivate colleagues in Africa, in particular also Africa CDC, to have this bridging element included, to reach out for the veterinary partners, and also to establish those cross-sectional aspects of laboratory external quality assurance.
Thank you very much. Is Dr. Andreas on for your last remarks? Okay, so Andreas is not on. Colleagues on the screen, again, thank you for joining. We have the code for accessing your certificates for those that need it, and we think you do. Please be able to access your certificates through the code that is available. Again, thank you so much for joining us, and we wish you a very good day, good evening, and good afternoon, wherever you're joining us from. We will be having yet another session as and when they become available, and we'll let you know. The slides for this session and the recording will be available on our online resource center, and as soon as they are available, you'll be able to access them. We'll also try and make sure that you can get the slides through your email addresses. Thank you again very much for joining, and good day, good afternoon, good evening.